Hello everyone, my name is Greg and I dev stuff. Welcome everyone to episode 2 of Stardew Valley like game in Unity. In this episode we will cut the tree and create an item pickup script. Very first thing you will probably notice is that I use Unity 2020.1 version, which comes out with Dark Unity theme, which is way better on my eyesight. Update came through smoothly and without any issues. But if you are from the future or you don't want to update, barring some rare cases of new features, older or newer versions should work well with this tutorial. Good. So in this episode the very first thing we want to do is to create some kinda environment for our character. To do that we will use a Unity tile map. Select overworld sprite sheet. Make its sprite mode to multiple to allow us to slice the sprite sheet into the pieces we can reuse. Then set the pixel per unit to 16, because each of those pieces is 16 by 16 size. If you have a different sprite sheet, you need to look into the base size of each sprite on the sprite sheet and put it here. Pixel per unit will make it so if you select the individual sprite placed on the scene, the distance between 0 and 1 by x or y axis will be equal to the size of the sprite. Good. Save the changes and open the sprite editor. We know that this sprite sheet uses 16 by 16 base size for the sprites. So click on slice and select grid by cell size. Input 16 by 16 and click slice. Then click apply and close the sprite editor. Good. After Unity is done importing stuff, now we have ready to use sprite sheet for our sprite map. Now let's create a tile map. Click on game object, then click on 2D and select tile map. Good. Now we have a tile map on our world. But we have some kind of way to edit it. To do that, click on window, then click on tile palette. To define sprite sheet, you need to create palette. Click on create palette. Select and drag our sprite sheet into tile palette. Now this will create tiles for your sprite sheet. Let's create separate folder for the tiles and select it as a folder to save our tiles. After Unity is done, you will see that in the tile palette there will be small tiles with which we can draw our map. For now I will just make a green floor for us. We will be coming back to this tile palette later on and cover it more in depth. Okay, now we want to create a tree for us to cut it. To do that we need to find and use some kind of tree sprite as our tree object. We have one in the object sprite collection. So let's drop our new created tree on the map and scale it a little. Good enough. Now we need an ability to detect our tree on the map for interaction. To do so we need to add a collider for the tree. Add a new component called Box Collider to D. If we launch the game right now, you will see that you can walk through the tree. It is because while our tree has a collider, our character doesn't have one. Add Box Collider to our character. If you try to hug the tree now, you will see that you can go through the tree. But if you slide around the corner, our character will start rotating for some reason. We don't want this to happen, so disable the rotation on the character's rigid body. Good, now we want to create a system which allows us to interact with the tree and cut it down. In our games there will be two types of interactions. One is when you approach something and press interact button, and one when you use tools. First type will be covering stuff like opening chest, talking with people, pressing buttons. Imagine moment when you approach something and it says you need to press X to open this chest. While second type of interacting with objects is done through tools interactions. If you swing your axe, it should be able to detect the object in front of you, which potentially can be cut by the axe. Let's start working on this from tree perspective, so to speak. What we want to do is to create a system which allows us to describe our objects if you strike them with the tools. To do that, we will use inheritance. We will create a base script where we will describe virtual methods which will be inherited by all objects which can be struck by your tools. Then we will create an object-specific scripts which will be describing the reaction of the object to this action. So for example, if you're trying to cut the tree with the axe, it should react in the way as tree will react to being cut. Later on we will be able to use the system to describe stuff like mining the ores. Create a new script called toolHit. Inside this class we will create a public virtual method called hit. Keep it empty. Now select the tree and create another new script called treeCuttable. Open the newly created script. Inherit from toolHit class. Now we want to override our virtual method called hit. Then inside this method we want to simply say destroy to this game object. For now, of course, we will be implementing more complex reaction later on. Good. Now we actually want to give our character ability to swing his axe and detect the, tree in front of us. But before we continue, let's fix rotation of our character. Right now, if you move, your character faces the correct direction. But if you stop, your character will face some kind of direction unpredictably, and still going to be animated like he is moving somewhere. So let's fix this. First open the animator and add two new float variables, last horizontal and last vertical. Open the character controller to D. Inside we want to determine if directional buttons are pressed or not. Cache the axis raw, horizontal, and vertical into the variables. And replace the input getAxis with the cached values. Okay, now we want to know what was the direction of the motion vector right before our player stopped pressing the directional buttons. To do that, check is ours horizontal or vertical is not equal 0. If they are not, store the motion vector into a new public variable called lastMotionVector of type vector2. So while we are pressing the buttons of directional movement, we will be saving our motion direction into this variable. So we can use it to determine the direction of the interaction and for animation purposes. Normalize this vector, then assign them into the animator. Because animator transition can check for not equals without unnecessary cluttering, let's create one more field in the animator called moving of type bool. And in the character controller set it based on our character in motion or not. Add a moving field into the animator. Then in the animator, let's create a new blend tree. Call it idle, and use last horizontal and last vertical in the similar manner as we did with movement. In the next episode I will get the new sprite sheet for the characters, and we will replace the current animation with the new one. Connect the idle and movement between each other, and let's define the condition for the transition. Uncheck the has exit time, remove the blending between states, and add condition, which will check for state of moving. In transition from idle to movement, check is your moving state is true. And in transition from movement to idle, check for it to be false. Make idle your default state. Launch the game, let's test it. Select the character and create and add a new script called Tools Character Controller. Open the newly created script. First, on the awake, let's cache the reference to the character controller 2D and to rigid body 2D. We need to do that so we can use last motion vector as a direction of our character facing. We can use it for direction of our character interacting with the environment, so we will not be able to cut the tree while facing it with ours back. I recommend doing this trick. You initiate all necessary classes and store all necessary references on the awake, and start doing operations with them in the start. This way, if you keep doing this across all components in your game, you will have your game store all necessary reference at the awake, and only after it is done, it will proceed to do some kind of operations with them. Of course, this is not silver bullet for all the cases, so you need to make a decision based on your particular situation. But it is better to keep following certain pattern and only change it in case you have to. Then inside the update check, if we press left mouse button, in the case call and create a new method called useTool. Inside the useTool method we want to detect do we have something what we can hit with our tools in front of us. We want to project the interact area in front of us to calculate position in the direction of our character facing, multiply the last motion by the distance of the offset from the character, and then add this to the character position from the rigid body. So let's define offset distance, serialized float variable, and serialized float variable for the size of interactable area. Then we do overlap circle all to get all colliders inside the circle in front of us. Store the return colliders into the list and cycle through them. Then check does it have tool interactable attached to it. If it does, call hit and break out of the cycle. Let's test this. Good. Let's make the cool Roomba-like script for picking up dropped items. In our case it will be 3 logs. First let's take the log from our overall spreadsheet. Drop the sprite on the world map and scale it down. Create another new component called pickup_item. Open the pickup_item script. Declare new variable of type GameObject which will reference player on the scene as a transform. Declare new serialized variable of type float called speed. This variable will be responsible for the speed of moving the object towards the player when it is being picked up. Serialized float variable called pickUpDistance with default value of 1.5 and serialized float variable called TTL or time to leave with default value of 10. Good, now we want to do very simple system where we will check for the distance between the character and the object to determine should the object start moving towards the player or not. We are using this system because those items will be dropped from some kinda sources and will be despawned after some time passed, so there will never be a big amount of those objects on the scene. At the same time, it will not going to stay persistent in the world. After you move areas, those items will disappear and that's it. They will be gone or they will be cleaned after certain amount of time passed. First store the distance between player and object into the variable. Then check if the player inside the pickup distance. If he is not returned out of the update, this will stop execution of the update function, so if the statement is true, then everything below this will not be executed. This trick is called guard clause. Then move the object towards the player. Use speed multiplied by time delta time as a step. And if the distance is lower 0.1, destroy the object. We will be implementing inventory later on, so we will come back here to add the item to the inventory. Good, now we are left with one bit of the problem. We need a player reference, but we don't have one. Of course you can make the player reference public or serialized and place the player in the scene. But this is not a good way to do this, for simple reason of, well, you want to do this automatically, So to be able to give your system easy access to the character reference on the scene, let's introduce a singleton which will be storing all often used references, which anyone who needs them at the moment can request. Then create and add a new script called GameManager. Open the newly created script. Good, now we want to declare it as a singleton. Then create a public reference to the player character. Go back to the scene and assign the reference to the player. I forgot to attach the script to the game manager, so do that. Open pickup item and on the awake store the reference to the transform of the player character. To do this you can call singleton like this and access its members. Let's test this. Good. Now inside the pickup item slowly decrease the time to live by time delta time. And when the time to live is less than 0, destroy the object from the scene. Let's test this. Yes, after 10 seconds, your object should disappear. If you want to change the time the object stay on the scene, you can just change time to live in the inspector. It will be in the seconds, so 10 means 10 seconds. Prefab the log. Now we want to make so when you cut the tree, logs drops. Open tree cuttable. And let's introduce serialized reference to the pickup object prefab. Serialized integer called drop count with default value of 5. And serialized float variable name spread with default value of 0.7. When you cut the tree before destroying it, we should spawn our slug of wood, so player will be able to pick them up. For that, we will use while cycle. We will be spawning logs until the drop count is more than 0. So to make sure that we will not forget to decrement our drop count, making this loop stuck, let's add it right now. Then we want to calculate the position where those logs drop. Use the current tree position and adjust the position of x and y axis by your spread. To randomize it, we will multiply our spread by value and decrease it by itself divided by 2. This will make a value between negative half of the spread value and positive half of the spread. Then instantiate the prefab. And assign a calculated position. Let's test this. Good. Good, this is it for this episode. If you have any questions or any ideas about code, please leave your comment below. If you are interested in seeing what will come out of this, please subscribe. If you want to support further, you can find my Patreon in the description. With best regards, see you in the next episode.